Good morning. Today I am going to show you how to run a emotion detection program or how to write a emotion detection program for your final year project. So let's start. So in order to install some of the library which we are going to use in emotion detection system, we have to first open the command prompt. So as you can see, we open the command prompt. So we need to install some of the libraries the libraries which we are going to use in running the emotion detection system. So first we are going to install some sort of the library. So let's install. So first library which we need is TensorFlow. Basically TensorFlow is a machine learning library. This library has many functions for training the machine learning model. So as you can see, our computer is processing. So as you can see, it's showing error. So here again we are going to try this. So as you can see, it is downloading. So basically we done some mistake here, like we have to write spelling mistake in the TensorFlow. So be careful when you are typing some of the libraries name. So here you can see we used E as, but we need to use O. So it is a like TNSO or TensorFlow. So it is downloading. It will take approx 2 minutes to download. So I'm going to show you the code which we are going to use. So we already installed the Python. So as you can see, we opened the Python shell. We are now going to open the file which we are going to use in this program. So here is the emotion detection system file. So we need to install the library like TensorFlow, Matplotlib, CV2. It is a basically computer vision Python and NumPy library. So basically these library we are going to use, and as you can see, almost TensorFlow is completed. So in the when you are downloading TensorFlow, NumPy will automatically get download. Here we used the NumPy, so we didn't need to download NumPy separately. So as you can see, after installing the TensorFlow libraries and during the installation of the TensorFlow library, we already installed NumPy library. So now we are going to install argparse library. So now we are going to, for installing any library, we are using pip command. Actually, I have done some spelling mistake. Pip install. When you are typing any library, be aware of the mistake you made during the typing. You have to write the name correctly. It is a most common mistake people do. So now you can see our library argparse is installing. So it's got installed. Now we are going to install matplotlib. Pip install matplotlib. So as you can see, matplotlib is library is installing. Basically we use matplotlib in graph related work. So when we are training the model, we want to show the progress of the model, our machine learning model. For that purpose we are using matplotlib. So it is installing, and you can see we already installed the TensorFlow library. So we do not need more, we only need last OpenCV library. So here this library is installing. I want to show you something, the structure of the program. So here you can see we have the data. In the data inside test folder, there are several folder like angry, disgusted, fearful, happy. These are the image samples. Suppose we are opening angry. So here you can see the angry faces of the people. So these are the basically image samples. Here are the disgusted emotions. So basically with the help of these images, happy, first we are going to feed these images in our program for training purpose. So after getting training, after when our file got trained, then we use that trained model for detecting purpose. So as you can see here our this requirement, our matplotlib got installed. Now one last library is the OpenCV Python. So we are going to install pip install OpenCV Python. So again we can see here, so these are the image samples which we are going to use. So remember the folder tree. So inside data folder there are two folders like test and train. For test, for training the training the model, we use train folder. So here we have image samples like angry image samples, disgusted image samples, fearful image samples, happy image samples, neutral image samples, sad image samples, surprise image samples. These are the sort of the image samples which we need. So you can download these image samples from Kaggle website. Kaggle is a data science website which provide you the data related to the machine learning model. So from there you can find this folder easily. So as you can see, our all means like our all package which we require for running this program is installed successfully. Now we come to program itself. So here you can see here import numpy. Numpy is a basically number library. It's like it do matrix addition, matrix dot product, cross product. A matplot library is used for basically graph purpose. If you want to show the progress of our machine learning model. And import CV2. CV2 it is basically OpenCV Python. It is basically computer vision library. It's like it detecting face. First we are going to use CV2 library for detecting face. After detecting face, we are going to detect emotion. So there is the two step involved in that. First we are going to detect the face. In next step we are going to detect the emotions. So here you can see import os dot information. In environment we are going to choose the environment. Like basically this statement basically it's going to use for like if your computer support GPU or CPU. If you want to train through GPU, basically we use GPU. If your computer support GPU, so this program can run fast or this program get trained fast. By default it is CPU. So there is the mode. So you can see here AD arc based argument parser. So basically if we want to when we are running this program through command prompt, then we are going to use this statement. So or unless we are not going to use this statement arc based. So if we are running this emotion.py Python program from our command prompt, then we use both these statement, or unless we are not going to use this statement. So here you can see the mode equal to display. So first we are going to change mode to train, because we need to train the file. So we change the train. So here you can see plot model history. This is the basically a function. After training the model, this function is going to show us our accuracy of our model. Here is the data train. This is the folder location. I told you have to remember that folder location. So I will going to show you. So here is the inside data there is a folder train, and inside data there is folder test. So this is that. So this is the location of that folder. From that folder we are going to access the images of the different sets of the different classes like angry, disgusted, and after accessing this image we are going to train this image in our program. So here you can see num train, num batch size, import size. Epoch means basically how many time we want to train, like 50 is a 50 time we want to train. So more epoch means more accuracy, means your model work good. Batch size, how much in one batch, how much image you want to give. Num train and num value, it is the number of the image. For training purpose, how many image you are going to use. For validation purpose, how many image are you going to use. So here is the train data generation, validation, data generation. So for training purpose we are going to generate the image. So here we are using rescale. So we need to rescale the folder, like our image are basically in range to 0 to 255. So we are doing 1 by 1 point divided by 255. So basically we are using rescaling for this purpose. So here you can see train generator, train data from train directory, the directory which already given. Target size means image change into 48 by 48, and here is the batch size. You already mentioned what is the meaning of the batch. Yes, the color mode is the gray scale. Basically our image going to change in the gray scale. And class model is categorical. Categorical basically we are going to use categorical, means it going to change the all classes into category, like 0 category, 1 category, 2 category, something like that. Like you are seeing here we have 7 classes, 1 2 3 4 5 6 7. So it's going to change in the category. So in first category that much image, second category that much image. So for that purpose we are using class model categorical. It is basically a binary model we use. So here you can see we are going to first create the model. This is the sequential model. Basically sequential model is a sequential neural network. So what going to happen, our image going to change into numpy array, and that array are going to go through the neural network. So in first layer we have 32 neurons, in second we have 64, and we are using activation ReLU function. Means when this activation function means when our neurons going to get fire, or when our neurons not going to fire. It is basically for that purpose we are using activation. So here you can see our input say 48 by 48. So basically it is a 48 pixel in length and 48 pixel in the width. So here we can say we already changed our image data set into 48 by 48 pixels. So for that purpose we are using that 48 by 48 and 1. And the dropout model dotted max pooling 2D. Max pooling, what it does, it basically it take 2 by what it going to done. So in max pooling it's take 2 by 2 one 2 by 2 2 by 2 window, and on that window it's going to pull that window pulling image. And in the same way the dropout, we use dropout for dropping some of the data like 0.25. So means in our neural network we are dropping some sort of the data. So we are so the purpose of the dropping, so our neurons not get overtrained or under trained. For that purpose our neurons get good trained. For that purpose we are using dropout. And flatten, which means in last step, like after training, so after going through 4 or 5 layer we are using flatten. Flatten is basically our data set got flattened in last stage. You can prefer to any neural network diagram. So I am going to show you the diagram, means like the diagram of the neural network, what it seems like, so you can understand better. So this is the neural network diagram. So here you can see so first layer is 48 by 48 hour, and between that there are many layers like max CONV2D with the conventional network which we are using, and last step we get the category from which class our model belongs to. So for that purpose we are using this neural network. So you can see here input and output, hidden layer. So we had also many hidden layer in our program. You can see that. In last step we are using the activation function softmax for, because softmax is we done lot of trial, scientists done lot of trial and error, and they used to know the find that the softmax is the best function to use in the last step. So here you can say we have 7 classes because we have 7 category. So basically what it happening, 48 by 48 image is going through our neural network, and in last step there are 7 outputs. 7 output prefer to 7 classes, the 7 category like angry, happy, and it's going to say tell us from which category our model going to belong. So now we are going to train this program. Basically mode we are going to change into train. So here you can see we used if else program, if mode equal to train, so this code going to be execute. If mode equal to display, then this code will be going to execute. So first we are going to mode into train. So run this code. So for the training purpose, so when we are training the classes, it takes basically time, and after training the model, it saves that model into model.h5. This is a basically file. This is the basically the file which in which the all the data got saved. So basically this step takes lots of time. Sometimes it takes 1 hour, sometimes it takes 2 hours, sometimes it takes 3 hours. It is a very lengthy process, and it is very time consuming for process as well as. So the in some time it will got it will start training. So I already had trained file model.h5, you can see here. I can show you. So here we have already have model.h5. So I didn't need to train that file. If I am going to train the file, it you should must train the file, because you didn't have model.h5, because I already trained. So this step takes lots of time, like 4 hour, 5 hour. So you can see it is still not started. It takes lots of time. So we are going to go to the next step, like display. So here the model which we trained, the model.h5. So here you need to change the train to display. So in display we are going to load this model.h file, the same file which we trained in previous, in first mode, in train mode. That same model.h5 we are going to use in to load the model, because what happening in our first step, in first we need to at least we need to run this train file model.h one time. So after running this one file, all the data gets stored in model.h5. After running this code, after running this model.h5, we need to just load this file. So as you can see, SkyPy is not, so it is showing error. Basically it is showing SkyPy is not found. SkyPy is also library, so we need to first install the SkyPy. Pip install SCIPy. So it is installing. So in the same way, you have to debug the error. When you are running the machine learning model, you will face many error, like I am seeing here name error, name SkyPy is not found. So basically SkyPy is the library. So the majority of the error which we encounter in this program, I mean in the machine learning program, is consist of the module not find error or name not find name error. So this basically this error occur when we did not install the all library and we are training the model. So first we need to install the all library before training the model. So as you can see, so in first step we need to train, in second step we need to the model, all the data which got saved in model.h5 we are going to load in model in display mode. So we need to train the model only one time. After training one time, you can from second time when you get the model.h5 folder, means file, after, so this program create one file named model.h5. so the main purpose of the running this mode equal to training, for training to get this model.h5, because this folder is nowhere available on the internet. You have to create this folder through your program only. So after getting this model.h5, we did not need this code. From next time when we are running the code in the mode of display, we just need to load this file. So in first time when you are running the program, so for training purpose it take time, and from second time when you are like running the program or detecting the emotion, you didn't need that file. So again we are trying to run this train mode. Let's see what happened. Okay, so basically we are running the program, so to get that model.h file h5 file only. It takes some time. If and else, you can see here we are checking if mode equal to train or if mode equal to display, and here we mention the mode. So when you are running the first time this program, you need this part of the code. From second time when you are running this program, you didn't need this code mode equal to 10. You just need to change here mode equal to display, and you can easily run this code, and it didn't take that much time also, because when we are running the first time this program, it go through training phase so that it can create model.h5 file. So here you can see train mode equal to train. So we are going to run this program. So we change into mode equal to train. By mistake we didn't change the mode equal to train, so that's why it is not getting trained. So now we change the mode equal to train. Now it will get trained. Now it's first get trained. After getting trained, we are going to save this file model.h5. Basically machine learning is a very time consuming process. You have to be patient. It is showing warning, but still our code is running. So here you can see epoch is 1. So total 50 times this neural network is going to run. So here this is running, this code is running. So training is started. When you can see epoch is started, means training got started. So what happened after means like 3 or 4 hours, like it have to run for 48 times and into 50, something like it take 2-3 hours to run completely to complete it. So we come after we wait for 2 and 3 hours. So basically I already completed this step 3 hours earlier, so I am just skipping this step to show you what happened. So let us skip this step. What happened after it run, after this file got this epoch equal to 50 completed 50, then our training file got saved. So I am skipping this sketch. So basically you can see here our file .model.h5 h5 file. This is the file which got saved after training. When you train the model after training like 2-3 hours, this model.h5 got saved. So now we are going to change our mode to display. So now we want to detect emotion on our face. So now we are going to go through. So I will explain what happened in display portion of the code. So basically we are going to load this model.h5 file. This is the cp2.ocl set use OpenCL false. Basically it's used to prevent OpenCL usage and unnecessary logging message. This is the dictionary, basically emotion dict. So basically when we are training the program, we announce some code like 0 for angry, 1 for disgusted, 2 for fearful. This is the categorical. I already explained here. You can see here there is a categorical class mode. So we are changing in the category. Cap equal to cv2.video capture. Basically it open the camera and retain frame. This basically going to read the frame which we are going to read from this line. Means basically frame by frame it is capturing our image frame by frame. And the face CV2 cascade classifier is a basically it is a basically XML file which we are going to use detect our face. So in first step, here you can see here cascade frontal face default. This is the XML document you can easily find on the internet. So what it's going to do, it first going to just detect our face, that much. And in the next step we are going to, from detected face we are going to detect the emotions. Here is the gray, we are going to change this our face to gray. And for XYWH, this is the length, breadth, width and height. So basically it's going to draw the rectangle on our face. And after drawing rectangle on the face, it's going to predict, and it's going to predict the emotion on our face. So basically here you can see we are using cv.putText. So basically it is the putting the predicted value which emotion which got detected on the corner of the our face detector, or the corner of the means like corner of the rectangle. But it's going to first detect our face, and on corner it's going to write whether we are which emotions we have. And cap.release basically it stop the camera, and CP to destroy all window, it's going to destroy the window. Basically when we are detecting the image now, it's going to create a window in which they are showing the images. So now run this image. So basically try to run. Basically already my camera is running, so probably it will run. Let's see what happens. So you can see that our code is running here. It is showing our class neutral, happy, surprised. So according to my so you can see according to my face emotion, it is showing the classes. If I am happy, angry or sad, it is like 80% accurate. So in this way we are going to create a machine learning model for our emotion detection.